Hi, my name is Shahriar Shahramian. I am the director of the Sensing and Communication Devices Research Group at Bell Laboratories Nokia. And I'm here to talk to you about the work that we've been doing for D-band communication, in particular for backhaul point-to-point radios operating up to 170 GHz. We presented some of this work at the RFIC 2020 Symposium. This is the result of the work of some passionate and dedicated engineers in our group, and I suggest that you download the full paper to get all the fun details. And it's undeniable that our demand for data continues to grow. In fact, in the past few years, because of the development for 5G communication, some incredibly integrated and sophisticated phased array devices operating in millimeter wave frequency have become available. Of course, this is only part of the network. If we want to make the vision of 5G a reality, we must upgrade almost every aspect of our network. That includes our fiber optics, our backhaul, even our copper communication devices. Even with a really good RFIC, you still need to get the signal from the RFIC into the antenna. And that interface cannot be very lossy, otherwise it will undo all the performance of the RFICs. And for that, we have moved on to glass. Glass is a really interesting material because it gives you very good lithography, and with some clever design, you can get some really good loss from these. So these devices here have an interface loss from the RFIC to a waveguide port of an antenna less than a dB, up to about 150, 160 GHz. These are extraordinary numbers, which means that we don't lose a lot of performance by packaging these, which has always been a problem at D-band frequencies. This is at the same time an interposer, an interface to the antenna, a BGA package, and of course connects all the signals to the chips. We call this radio on glass, and we believe that this is the next generation of ultra high performance devices operating at these frequencies. We've created wireless links with these. By putting them on a regular PCB with a waveguide interface at the back, we have emulated a link of about 250 meters by putting a 10 meters in between, and we can do 256 QAM or even higher modulation up to data rates that support ultimately 100 gigabit per second wireless link using MIMO. We have in fact built phased arrays on glass using some of our own phase shifter elements, LNAs and PAs. These are single chip phased array elements. There are 8 of them on this module. And we have measured EIRP of 44 dBm at 140 GHz, which again is a world record, especially because of the level of integration and the phased array on glass architecture. And this is indeed a very interesting domain to explore, with a lot of innovation still to come. We could potentially build a backhaul radio completely on glass and be able to have this extraordinary performance going even above 170 GHz in the future. And I want to thank you for your attention and for seeing the work that we've done at Bell Labs. We look forward to continuing this research and hope to see you in person.